Hello, myself Rajini Suresh. In this session, let's discuss with respect to iron making subject. In that, iron making historical, unit 1. In this session, let's discuss about exhaust gas utilization, hot blast generation. Already, we have been discussed with respect to ancient iron making, historical iron making. Then now, let's discuss with respect to exhaust gas utilization. What is this exhaust gas? This exhaust gas, which is coming out from the blast furnace, when coke burns to form carbon monoxide, carbon dioxide, nitrogen, hydrogen. All these contains the gases which will be coming out from the blast furnace. Under pressure, when it is coming out, it's called as exhaust gases. So when we leave this exhaust gas to the environment as it is, which will leads to the environmental pollution, health hazards. So to avoid such kind of pollutions and health hazards, the exhaust gases can be collected. Before collecting, it is cleaned, then it is to be collected in the gas holders. This exhaust gas will contain carbon monoxide, carbon dioxide, nitrogen, hydrogen. Our main intention is to make use of carbon monoxide. So, this gas, without leaking anywhere, which is to be collected properly from the blast furnace through the uptakes, and which is connected to the single pipe known as downcomer. From the downcomer, the exhaust gases from the blast furnace, which is comes out and collected in the dust catcher, where the exhaust gases are coarse cleaned. The downcomer, which will opens up in the dust catcher. So, in the dust catcher, the coarse cleaning of the gas takes place. Later, this coarse cleaned gas moves to the semi-fine cleaning into the wet scrubber, where semi-fine cleaning of the gas takes place. Later, next, semi-fine cleaned gas next moves to the ESP, electrostatic precipitator, where fine cleaning of the gas takes place. Later, that finely cleaned gas is collected into the gas holders and can be used as a fuel, which is highly flammable, so which can be used as a fuel in industries, and which can be used to generate heat in power generation, like all. Let's discuss in this session about exhaust gases. Exhaust gas utilization. In 1845, Bunsen and Playfair concluded that waste gases could be making use in furnace operation as a fuel and in power generation. So here in 1845, the Bunsen and Playfair, the persons, they concluded that enormous heat is wasting, enormous gas is wasting. So to avoid wastage of gas, to make use of that gases, they have found the utilization of gases in the form of fuel and to generate the power also. And this exhaust gases contains carbon monoxide that can be used in the stove burning, where checker brickwork can be preheated to preheat the blast of air. Then that preheated blast of air will be sent to the blast furnace through the bustle pipe. And this exhaust gases can be used in the kilns also, and which can be used as a reducing agent. That gas can be used as a fuel. Let's see what are the utilization of exhaust gases. So here in this picture you can see the exhaust gases coming out from the blast furnace that can be collected and cleaned in the gas cleaning system. Then it can be sent to the gas holders. And 25% of the gas is utilized for stove burning. 75% of the gas is sent into the gas holders. Here, let's discuss the uses of exhaust gases are as follows. Exhaust gases are used as a reducing agent. So here you can see the reactions. In the indirect reduction, there you can find out iron oxide is reduced to iron under solid state by using carbon monoxide gas. Indirectly, iron oxide is reduced to iron. And it can be used as a fuel, which is highly flammable. So this exhaust gases can be used as a fuel. Used in power generation. To run the turbines, the carbon monoxide gas can be used as a fuel. To produce steam, by steam the turbines are run and power will be generated. To preheat the furnace. So in industry, wherever it is required to preheat the furnaces, where the carbon monoxide gas is utilized for preheating and for drying purpose. And now lastly, to burn stoves. Already have been discussed. In the stoves, there will be a checker brickwork. We used to say as on gas, on blast. When the stoves are on gas, it means the stoves are getting heated themselves. So the stoves are getting heated themselves by using this carbon monoxide gas itself. When the carbon monoxide gas burns into the stoves, the heat generated by burning can be absorbed by the checker brickwork. Then the blast of air will be preheated around 1200 to 1300 degrees Celsius. Next, it is moved through the bustle pipe into the blast furnace as an oxidizing agent. So these are all the list of exhaust gas utilization. Next, let's see the hot blast generation. It means blast in the metallurgical technical word. Blast means pressurized air what we are going to inject into the blast furnace. The blast of air is to be injected into the furnace under pressure. That is called as blast. Here, anyhow we are injecting the air into the blast furnace. That blast of air, if it is preheated around 1200 to 1300 degrees Celsius, then we can maintain thermal efficiency of the blast furnace properly, and we can increase the production rate and we can reduce the production cost. So by keeping in this concentration, Nielsen, a Scottish engineer, in 1829 started that thermal efficiency of blast furnace could be improved by preheating the blast. The Nielsen, he stated that the thermal efficiency of the blast furnace can be improved by injecting the preheated blast of air. So, in 1857, Cooper developed the stove to preheat the blast of air. Air can be preheated and injected into the blast furnace under pressure. The air is to be preheated around 1200 to 1300 degrees Celsius. So here in this picture, you can find out the combustion chamber and checker brickwork and clay checker work. How does the stoves works? So the carbon monoxide gas enters into the checker brickwork into the stove. The heat generated by the burning of the gases, the checker brickwork absorbed the heat and kept the heat. When the blast of air is passed through the stoves, the air is preheated around 1200 to 1300 degrees Celsius, so that we can improve the thermal efficiency of the blast furnace and we can increase the production rate by reducing the production cost. So this is about hot blast generation. Let's discuss with respect to multiple choice questions. Wastage of heat at top of the furnace was demonstrated by Bunsen and Playfair, Cowper, Helling, Dudley. First, let's see the question properly. Wastage of heat at the top of the furnace was demonstrated. Here, it suggests as enormous heat is wasting at the top of the furnace. The exhaust gases, if it is left as it is to the environment, anyhow which will pollute the environmental air and which will lead to the health hazards. So, and enormous heat is wasting and it leads to the lesser thermal efficiency and production cost will be more and production rate will be less, time consumption will be more. So, already we have been discussed the Bunsen and Playfair. They have been demonstrated the usage of exhaust gases. That gas can be cleaned, then it can be used as a fuel and as a reducing agent and to produce heat somewhere. Apart from this, you can see here Cowper. He is the person, he has been invented the stoves to preheat the blast of air. Helling has been invented the pick casting machine in the 1894 to expedite and to mechanize the casting operation. The Dudley. They have been demonstrated the usage of exhaust gases and all. Let's see the question number 2. Stove for sending preheated blast was developed by. Stoves are used to preheat the blast of air and that will be sent through the blast pipe to the blast furnace through the tuyers. A huge bustle pipe is surrounded encircling the peripheral wall of the furnace. Through that, the tuyers are connected. Through that tuyers, nozzles, preheated blast of air is to be injected under pressure into the blast furnace. Was developed by Cowper. The person name is Cowper. Bunsen and Playfair, they have demonstrated that enormous heat is wasting at the top from the gas, so that gases can be make use by cleaning as a fuel, as a reducing agent, and all. Okay. Here, Bunsen and Playfair, both of them demonstrated. Then Stucofun, it is a furnace, which is progenitor of the blast furnace. Thank you. I heartily thankful for our program coordinator and moderator, Mr. Gauri Shankar Raymond sir. He is principal of Sanjay Gandhi Polytechnic College, Ballari. And myself, K. Rajini Suresh, working as a lecturer in Sanjay Gandhi Polytechnic, Ballari. And I heartily thankful for content developer, Mr. Swapnil Damlekar, RGIST, Thorangallu.